Good morning, my dear students. In the previous class, we discussed about the electric potential at any point on the electric dipole, and we talk about the electric potential due to the system of point charges. In today's class, we will talk about one important concept of this chapter, that is equipotential surface. We talk here equipotential surface. So, as the name indicates, equipotential surface, we know what is meant by potential. We know the surface. There is another term called as equi. Means equal potential at the surface. Any surface which has same electric potential at every point is known as equipotential surface. Any surface you can take, in which the potential is same at every surface, is called as the equipotential surface. Say that if there is a charge present and this is the lines of forces due to this positive charge, if I imagine a surface around this charge, then at every point on this surface, I get the same potential. Right? There is a positive charge, and you know that electric field lines are away from the charge due to the positive charge. If I draw the imaginary surface, then I say that at every point on this surface I will get the same potential. Then this surface is known as what? The equipotential surface. You suppose that any conductor is charged, then I must say that this surface has a constant potential surface. This surface has a constant potential at every point, here, everywhere. Only if I charge this, say that if I charge the 5 volt, then at every point I will get the same potential. This point. Everywhere I get the same potential. So equipotential surface means what? It is the surface which has constant potential at every surface. I write here, any surface which has same potential at every point is known as equipotential surface. You can take example, a spherical ball. If it is charged, then I get that at every point of the spherical ball has a same potential. Alright, so equipotential surface due to the positive charge. Equipotential surface due to the positive charge is spherical, concentrated spherical. Alright, so for every point charge, for every positive point charge, equipotential surface is a concentric spherical. So it has some properties. there are some properties of equipotential surface. Right? We write here properties of equipotential surface. Properties of equipotential surface. Right? As I said that equipotential surface is a surface which has constant potential at every point. Which has constant potential at every point. Suppose that this is the surface. This is the surface which has constant potential at every point. At every point it has a constant potential surface, so I will call this the equipotential surface. So one of the important property of this equipotential surface is, I will write first one, equipotential surface. On the equipotential surface, no work is done in an equipotential surface. No work is done in an equipotential surface. No work is done. No work is done means what? No work is done in moving a test charge. In moving a test charge from one point to another point on an equipotential surface. No work is done in moving a test charge from one point to another point in an equipotential surface. See here, no work is done in moving a test charge from one point to the another point in an equipotential surface. What does it mean? We know that potential V is equal to from one point to another WAV by, right? Therefore, this is the equipotential surface. This is the equipotential surface. And we know that on the equipotential surface, potential at every point is same. So that this is the point A, this is the point B. If I want to move a test charge, say that 1 coulomb, I want to move this charge from A to B. From A to B, there must be no work done. Why? Because the potential at every point is what? Same. Potential at every point is same. This is nothing but what? WAV upon Q. So you can write that this potential delta V can be written as what? That is VB minus of VA. VB minus of PA. Here is what? VA is equal to VB because potential at A is equal to the potential at B because what? It is the equipotential surface. At every point I will get the same potential. So delta V is equal to what now? If VB is equal to VA, then this must be equal to 0. Therefore, you can say that WAB upon Q is equal to 0. Therefore, no work is done in moving a test charge from one point to the another point in an equipotential surface. Work done is 0. Work done is 0 in moving a test charge from one point to the another point in an equipotential surface because the potential at every point is same. That is why we say that no work is done. This is the most important property. Alright? So, the second property says that for second property we say that two equipotential surface potential surfaces never intersect with each other. Never intersect with each other. No two equipotential surfaces intersect with each other. Say that we cannot say that two equipotential surfaces cross each other. This is one equipotential surface. This is supposed to be say that another equipotential surface. Say there are two equipotential surfaces. This is one and this is another equipotential surface. These two equipotential surfaces never intersect with each other. Why? Because there must be only one direction for the electric field. If there is a two equipotential surface, then for surface 1 there is one electric field in this direction. Say that it is E1. For equipotential surface 2, there is one more electric field, E2. And we know that it is not possible. Electric field cannot have the two directions at the same point. Alright? So there will be only one direction for the electric field. We cannot say that there are the two directions for the electric field at the same point. That is why it is highly impossible that two equipotential surfaces can intersect with each other. So no two equipotential surfaces intersect with each other. Right? So this is the second property. Two equipotential surfaces never intersect with each other. They never intersect with each other. This is one equipotential surface, this is another equipotential surfaces. So there must be the two directions of the electric field at the same point. It is not possible practically. That is why two equipotential surfaces never intersect with each other. Then third one, equipotential surface indicates the region of strong and weak electric field. Equipotential surface indicates the region of strong and weak electric field. Strong and weak electric field. Say equipotential surface indicates the region of strong and weak electric field. Here we have some diagram here. Say that if I suppose to say that electric field at this point, say at point A, I will get the strong electric field. As I move, the electric field goes on decreases. Say if I draw one more spherical surface here, I call the surface A, I call the surface B. At surface A, I get the more strong electric field. At surface B, I get little bit lesser, weaker electric field. As I draw the spherical surfaces like this, at point C, I will get even lesser than the B, weaker than B. So, equipotential surface indicates the region of strong and weak electric field. Say that at this surface, point A, I will get the more electric field. At B, I will get little weaker than A. At C, I will get the much weaker than the A, B and C. So, this region indicates the region of strong and weak electric field. And the fourth property is equipotential surface electric field is always perpendicular is always perpendicular to the equipotential surface. Equipotential surface. See here. Electric field is always perpendicular to the equipotential surface. Or it may be say that it is normal to the equipotential surface. It is normal to the equipotential surface. You can say that. As you can see, electric field is always perpendicular like this. You can see here. This is normal or this is perpendicular to the equipotential surface. Or electric field is normal to the conductor. Right? So, electric field is always perpendicular to the equipotential surface. Okay, so these are the 4 properties of the equipotential surface usually asked in the examinations. Alright, so in the next class we will talk about the electric potential energy.